Have you ever wondered what powers the sun, or how nuclear power plants generate electricity? These seemingly unrelated phenomena actually share a common thread. They both rely on a fascinating process known as nuclear fission. But what is nuclear fission? Nuclear fission, in simple terms, is the splitting of a large atomic nucleus into smaller ones. Let's break it down. Picture a game of cosmic billiards where a neutron, the cue ball, collides with a larger atom, typically uranium-235 or plutonium-239, our billiard ball. Upon collision, the larger atom absorbs the neutron, and a fascinating transformation occurs. This once stable atom now becomes a teetering, unstable nucleus, ready to divide. In the blink of an eye, the unstable nucleus splits into two smaller atoms, known as fission products, but the spectacle doesn't stop there. This splitting also releases additional neutrons, creating a kind of domino effect. These freshly released neutrons can then collide with other large atoms, causing them to split and release even more neutrons. And what about the energy? The energy. This splitting process releases a tremendous amount of energy, millions of times more powerful than a chemical reaction. It's this energy that powers nuclear reactors and atomic bombs. This process, while seemingly simple, requires precise conditions and control. So, nuclear fission is indeed a powerful process. It's the heart of nuclear power plants, providing us with a significant portion of our electricity. But it's a double-edged sword. This same process can be used to create devastating nuclear weapons. The key here is control. By carefully controlling the rate of fission, we can harness this power safely, preventing runaway chain reactions. Next time you switch on a light, remember the incredible power of nuclear fission that makes it all possible.